Hey friends, it is Ben. Um, I have noticed the fact that in class it seems like we don't get a lot of mileage out of my showing you stuff on the projector and things. So it occurred to me that I can save some time by recording a little video, which you could in theory watch tonight. I'll try to send out a note and stuff so that you get that. Anyway, what I'm going to do to in this video is to look through the Jupyter notebook that you're going to be working through tomorrow and point out how some of the things work so that in theory you will have that sort of a head start on it, and maybe you will have taken some notes, okay, to help you remember some of this stuff. And then in class I can just kind of circulate around and put out fires, and it gives you a little bit of a chance to get going a little bit faster and maybe get done faster because it'll be Friday. Okay, so in any case, I'm going to share screen here and we'll see one of those wonderful, that's nice. Okay, we'll see one of those wonderful Jupyter notebooks again. And this is the one you're going to be working on in class. So I'm going to try to point out stuff to you on this and see how that goes. So the thing that we're going to be doing is producing some visualizations. That just means graphs. Okay. So I'm going to real quick scroll down and point out the things that we're doing. One bit here, we're taking a look at the actual data that we've got. And then we're going to produce a bar chart. I'm sorry, but it so happens that I have a small computer screen that I'm working with. Can I do something to zoom out a little bit? Oh, it's a little bit. Okay, so you can see it a little bit better. So that is a bar chart where we've got the number of vehicles on the list grouped by their manufacturers. And notice down at the bottom, it has the manufacturers listed. Okay. And if you look back at the actual data itself, there are 234 rows of it. I've also got another set of data that's very similar to this that was called vehicles that had 45,000 rows. So we're looking at a smaller set. Okay. But we're going to see how to produce a bar chart and get it to label stuff on top of it. The colors part, I don't know what to think about those colors. Those are kind of wild choices. But we're going to take a quick look at how to pull out just one piece out of the data and look at a column. And then I'm going to ask y'all to do something here. And I think the thing I ask you to do is to produce another bar chart. Okay. But then we'll talk about a pie chart that helps you kind of see percentages and how much is in different categories. So here I have it done by vehicle class, and those classes are like compact, midsize, minivan, pickup, some subcompact, SUV, and two-seater. I'm surprised at the number of SUVs here. So I suspect that this was data from the 90s because we have, I don't know. But then I'll ask you all to do something similar. And then we're going to do something with what's called box plots. You may not have seen these before, but the idea of a box plot is that you break things up into different classes, and then this box here represents the data that we've got. So the highway mileages, there's a bunch of different numbers for the compact cars. And this is saying that the median, it's the middle line of that box there, is probably about 27. Okay. And then that the quartiles, if you don't know what those are, it's the 25% mark for a set of data. Median is the middle, but the quartiles look like they're at 26 and 29. Okay. And then these things that we call fences, which it's hard to explain to you exactly what they are, but they kind of tell you where the data really changes from being data that you expect and being outliers. The dots off at the end are outliers in the data. So, um, so for each one of these, you're able to make some comparison. So you see, for instance, here that the compact cars and the mid-size cars have about the same median and quartiles, but the upper end of the gas mileage for the compact cars is higher than the upper end for the mid-size cars, and has a couple of outliers there. Then you can make similar comparisons for everything else, seeing that SUVs and pickups are about tied for the worst mileage, and subcompacts versus compacts. It's interesting there that there's a compact car that's an outlier that goes beyond what these subcompacts go out for. So, all right. And then I'll ask you to produce a box plot as well. Basically on these that I'm asking you to produce, it's copy the code and change the right things. So anyway, yeah, and suggestion for something else to do. Then scatter plots, I think you've done those on the stuff for Thursday, so you probably already know what to do on these, but it has this notion here that we are looking at a few of the data points so we have an idea what's going on, and then we are taking a scatter plot in a certain way. And if you notice here, this SNS that's there, that's talking about that we're going to do something with seaborn. Okay, but that gets you a scatter plot. And then the fourth problem is for you to produce a scatter plot. So let's go back and look at some details real quick. All right. So in the first bit here, there's some of it that I'll just leave to you to read, but we have our import statements in here. And the new stuff that we've got is that we're going to do something with the seaborn package. The seaborn package has a lot of data handling tricks and does some visualization stuff really nicely. So you probably want, by the end of this course, to know things about pandas and about seaborn. And of course, I think matplotlib is pretty cool, but other people are just kind of shrug at when I say that. So it's an older set of things. So, okay, so after the import statements here, we have this line, which you'll recognize just is the assignment of some numbers. It does something new you haven't seen before with using a semicolon. All that's really doing is to separate out so that you can have multiple assignments on one line. Don't know that that's all that important to you, but you know, if you were doing a lot of things that are very similar, you might want to group them together easily like that. And then there's something here where we say parameters, and it, because we get the curly brackets, I believe that is what we refer to as a tuple. Okay, I was thinking those were with round parentheses, but maybe I'm wrong. Anyway, though, we are going ahead and saying here that things like the axes title size is going to be the large, and so that's going to be a 22-point font, medium, and so forth. Don't worry about these so much unless you sometime have to produce a graph that you have to fiddle with certain specifications. By way of example, a doctoral dissertation or a master's thesis for a particular school might insist that diagrams have things in a certain font, a certain size on the labels, and all kinds of crazy stuff. But after setting these parameters here, this then goes ahead and says PLT, that was the plot package, RC params. Okay, so it's apparently setting some parameters or something, um, and it updates them by giving those parameters that you specified in here. Okay, and then there are some other things that I went ahead and took out here as I was dealing with it. You might experiment with putting them back in and see what it does. As I mentioned here, they define backgrounds, but I don't recall that they were all that big of a deal one way or another. And this inline line, I'm pretty sure you want to leave that commented. Okay, just don't mess with that, but left it in if you want to experiment. So then the last bit on here is one that you've seen before. We're importing data. We're using the pandas package to import it. We are doing read CSV. That means that you've got your data in a comma separated values file. And then in this case, we've got a URL for it, and it's saved out on GitHub. So that ends up being kind of a convenient thing to be able to call stuff from there. This way, this in particular is nice because it will let you use it whether you are on Anaconda or using this other thing here, Google Colab, okay, because it's referencing to a URL. So anyway, though, then here when I say df_raw, notice in the previous one I said df_raw was going to be the name of the data file, the data frame, I should say. But this is the raw version before we've separated it out into pieces and stuff. So when you type just the name of a variable and hit execute on it, it's going to go ahead and try to list it there. If you're doing this on Colab, somebody pointed out to me that it would put this magic wand up there, and if you click on it, then that table becomes something that you can actually scroll through and tell it how many per page you want it to show and stuff like that. That's pretty handy. It's basically makes it look more like a spreadsheet. Okay. So some of y'all probably have some experience with spreadsheets, and you may often look at this and say, I can do all this stuff in Excel. Why am I bothering to learn about how to do it with Python? Python can do some things that you can't do on Excel. So this is just giving you a couple more tools to work with. So, all right. Anyway, though, once you can see that, the main thing to notice is the heads of the columns have these names here, like model and manufacturer and year and things like that. Okay. And we're able to then talk about like record number 0 that has the manufacturer entry of Audi, model of A4, and a displacement of 1.8 liters. The year is 1999, 4-cylinder automatic transmission, F for front wheel drive, 18 miles per gallon city, 29 miles per gallon highway, FL of P. I don't know what that one means. But then class is that it's a compact car. So anyway, this thing of just printing things out lets you take a look at them. So let's look at how we get this bar chart here. As a reminder, it's got a label that says number of vehicles by manufacturers. I guess that's a title, not a label. It has each of the bars with different colors and the number for the number of vehicles that appear there. I don't like that it says 14.0. I wish it would just say 14. There's probably a way to fix that. But, and then down below, we went ahead and put the names of all the models of cars, and we put them on a slant. So let's see how to do all those things. So looking down through here, the first thing we did for DF was to take the DF raw that we just got, tell it to group them by manufacturer, okay? And then this size part will tell it how many to have in that. And then this bit of reset index, and the name equals counts. Yeah, it's going to read the manufacturer column, group them, and then count them, and make a column of counts for it. Okay. Okay, so then we go ahead and say here n, because that's going to crop up in a few places, and it is the number of unique manufacturers, and we take the length of it, and then we go ahead and add 1, because it's always going, it goes 0 to n, it goes 0 to 10, and that would mean that there's 11 of them, so we're putting the +1 for that. Okay. Then here for colors, all colors is a list, PLT CM, colors, CNames, keys. Yeah, I don't know of anything that you'll do to change that, but yeah, it looks like it just determines what colors are available. Oh, right. And then the next bit here, we randomize. We tell the randomizer that we don't want to seed 100, so it'll do the same thing every time. And then down here on the next, it goes ahead and says random choices put into this all colors, and K equals N. I don't know what the K is supposed to represent, but the N, of course, is the number of unique manufacturers we had before. Okay, so then we're going to look at how we do the actual plot. So far, we've just gotten the colors figured out and put the data into a format where it'll do stuff. So the plot plt.figure lets you put in these options about figure size, 16 units wide, 10 units high. I'm guessing those are centimeters, but yeah. And then dots per inch will tell you about the resolution on it. The higher resolution you get, the smoother any curves will look. But because of the fact that we have just boxes, the only thing that's going to affect is maybe the rendering of the fonts. So then we're going in here and we're saying plot.bar. This is going to come up in some stuff we do later. A bar chart. This is a bar chart, right? But when you tell something to do a bar chart, the first entry that you have is going to be the locations of the bars, okay? And when we say that it's manufacturer, those aren't numbers, right? So how's it going to decide how to order them? Alphabetically, okay? So it's always taking a guess about what order to put things in. If they're not numeric, it's going to go for alphabetic. If they're not numeric or alphabetic, I don't know what it'll do. So, but the second variable that you put in here is going to be the heights of the bars. So that's why it's got the counts that we created in the previous line. And then the color is going to come off of that C that we created up in line 8. And then I went ahead and set the width of the bars equal to 0.5. If you wanted to have fatter bars, you could set it up close to 1. If you wanted skinnier bars, set it down. But anyway, that's not really going to affect anything other than just how it looks. Okay. So anyway, though, that is going to go ahead and make the plot. And then I forget what this for loop does here. So it's for I and val in enumerate df counts dot values. Okay, so that sounds like it's going to go and pull. It's going to run through this with all the possibilities that you got in the counts. Okay, and then it says plt.text. Okay, I and val. So that suggests one of those must be going to get like the I honestly don't know whether which the I and the vowel actually are there. But the thing that it prints up at the top, it's going to go ahead and put float.val. Float means that it's going to have a decimal after it. So in actuality, we might change that to int.val and see if it changes things. Yeah, that was the thing I wanted it to do. I didn't like those decimals at the end. Okay. So when you actually work on this, I'm going to leave it as saying float. And I want you to remember to change that to int so that, I'll know that you've watched the video. Anyway, though, horizontal alignment being center, vertical alignment being at the bottom, font dictionary, font weight 500 and size of 12. Okay, I guess that's just telling it how it's going to write those numbers at the tops of the bars. So, as it says on this line below it. But then there's some decoration stuff here, and this is something that you'll have to change in the one that you're doing. It says set X tick labels. That means on the X axis, the bottom, what the labels are on each of the bars. It says DF manufacturer. So I think I'm having you all do it by class instead of manufacturer or something like that. And so consequently, you will have to change this to what it's telling you to group by. So see how this has group by manufacturer, and then the ticks are the manufacturer. So this little bit here is kind of neat. Rotation equals 60, and that's the reason that it's on a slant. If you want to try some different things, you might put rotation equals 45 and see what it looks like. So, and horizontal alignment is going to end up being to the right side. And yeah, it's just all that's just basically telling it what to do with the labels. Okay. And then this PLT title tells you what you're going to say up at the top. And when you change it to something other than manufacturers, update it so that it looks right. Okay. And number of vehicles is the Y label. So the Y axis is going to say number of vehicles down there. And there's no need to do anything on the X axis, right? And then here, when it says Y limb, that tells you how far down and how far up it's going to go. So a common deceptive trick that advertisers will do is to give you some sort of well, I shouldn't say advertisers, but somebody might do is to give you a bar chart and like cut it off at 15 so that you only see how high things are above 15. And it kind of distorts your perception of how large things are relatively. So this is going 0 to 45 so that it's got some room above the top. When you change this, if you've got bars that are going out the top, you need to go back and change the Y limbs. Okay. And if everything you've got is really short, then you need to go back and change the Y limbs. Okay, so that it doesn't look ridiculous. But yeah, that's how that stuff goes. And so peeking at the actual data. Okay, so problem 1 here. What I want you to do is to copy that code, and instead of showing the manufacturer like it did, I hate the fact that it did that. It's going to show the class, like pickups, van, etc. Okay. And so with regard to that, because if I remember right, there are fewer classes than there are manufacturers. So you will probably end up wanting to change the fig size there so that it ends up being narrower or something. I don't know. But try to make it look good. So then if you've got the extra time, see if you can do the same thing, grouping things by the transmission, grouping things by the year that the car came out, stuff like that. Okay. Not really required, but if you have the time, it would be a good idea to experiment and see whether you can reinforce how you know to do things. Okay. All right, let's go down to the pie chart. So the pie chart, remember, has a label at the top that says pie chart of vehicle class. And I'll end up wanting you to do something different, right? But it's got these labels out to the sides. It's got the percentages in the middle. So a lot of it you'll be able to leave alone, but maybe not all. So if we look at preparing the data, this time for the DF, we tell it to group by the class and get the size then, okay? And then we've got a DF plot. So this time we're not using the PLT plot that came out of matplotlib. This time we're using something that came out of the data frame itself. Okay, so that means it must be something that's built into pandas. So here where you tell it the kind equals pi, you can guess what that does. If you Google pandas plot, you or probably Google pandas data frame plot, you can probably find different kinds that you can represent with it. So it says subplots equals true. I don't know what to say about that. Fig size is 8 by 8. Again, I think those are centimeters, but I may be wrong. Okay. But the important part is that the width and the height are going to be the same on it. So, and then this auto percent part here, if you notice, it has tick mark %1.1 F %%. And if you look down to what we've got on our labels here, we are getting them with one floating point past the decimal. I believe that's what that means there. Okay. I don't really know what the percents are doing. You might experiment with removing one and see if it makes it crash. Okay. But then the title, but pie chart by vehicle class, the Y label, it's going to put, apparently without putting that in there, it will put the word none up the side. So it's just a fix for a quirk of it. But as you can see, it pretty quickly gets things printed out there. And so it didn't require a lot of code to get that to work. Now, for y'all, you will be taking that code, copy and paste it in here, and modify it so you get a pie chart by the number of cylinders. Oh, why did I keep doing that? By the number of cylinders for the vehicles, right? And so that means that instead of by vehicle class, you're going to look for cylinders. And if you're like me, you may have to look back up here and see how was all that labeled. And cylinders was labeled CYL, okay? But so that means that you'll put CYL here instead of putting class. And you'll want to change, instead of saying vehicle class, you'll say pie chart of vehicles by number of cylinders, okay? Otherwise, should go pretty quickly. And then this line here, or this cell code, this code cell here, you ought to go back and see whether you can do it by manufacturer and do it by year, just to reinforce that you can see what to do to change things to make them do what you want. Okay. Not absolutely necessary, but so, make sure that you get all the basic stuff of problems done and then come back and practice. Okay. So then box plots we looked at before. So let's look at how we produce it. So it's a PLT, so that means something coming from the matplotlib library. PLT figure, and so we're setting the figure size again. After you get yours done, you may want to experiment with a different figure size to, make it look better, because if things are really scrunched up together or really dragged far apart, you can change things with the sizes and stuff. So then here, seaborn package does box plots for you. And the X values are going to be the class. So that's the thing that we are going to end up grouping by here. But notice we didn't have to do a separate statement to group by to get this to work. And then the Y values are going to be the highway miles. And so if you were doing city miles instead, you would make that change. So then your data is the DF raw, and this notch equals false. I do not know what that means. So anyway, then putting a title on there and changing the Y limbs. So if you notice here, none of the cars were getting below 10 miles per gallon. So it didn't make any sense to actually have stuff included below 10 miles per gallon. And then we kind of needed it up to 40 so that we could see some of these outliers and stuff. So, but that means that really this box plot took care of a whole bunch of stuff all at once. All right, so your problem is to break them up by manufacturer rather than by class. And I did that dumb thing again. So by manufacturer. So all the places where it says class, change it to saying manufacturer. And show city miles. City miles instead of doing highway miles. So that means all the places that highway appears, we'll change it to city. And is this over here? Yeah, I think it must go ahead and default to putting the name of the variable out to the side. So, okay, so go ahead and do that, breaking it up differently. And then if you've got the time, you might look at grouping them by transmission and getting the number of cylinders, because cylinders is going to be a numeric value that you have. So you might do transmission and displacement and see whether different kinds of transmissions tend to have higher higher displacement engines, larger engines. So okay, and I delete that bit there out. Okay. All right, and scatter plots. If you recall here, so I went ahead and said DF head so that we could see the tops of that there. Let's see if I go ahead and hit the magic wand. Yeah, it's still only showing 4 of them. Okay. But we're going to come in here, and I have every time gone ahead and taken DF and pulled DF raw out. But seaborn scatter plot, and then data equals DF. So you don't just say DF, you say data equals DF. And then the X that we're going to do on that is going to be the displacement, which is a numerical value, and the Y is going to be the highway mileage. So what we anticipate from dealing with cars is that a large displacement should give you a lower miles per gallon and vice versa, right? So if we take a look at what the data looks like there, yeah, and the plot's too big to get all on one screen, sorry, but we see that generally we had that trend. It's going down as it goes along. Okay. And so um, there's not much to that, you know. So, uh, by the way, if you notice here, we've got this deprecation warning, and that is something that lets you know that things have changed from one version of Python to another. And so, should a run async will not call transform cell. Okay, well, I didn't run async. I don't know what that means. So, okay, sorry. But your assignment on this is going to be to modify it. Let's see, modify it and put some options in. Color is called hue. Dot shape is style, and the size doesn't vary much. So, yeah, I would say to see what to do with that, go back here and see your command, your SNS scatter plot. Okay. So Google for seaborn, SEABORN, scatter plot. Don't put the dot and stuff, like separate them out. And then those options that I mentioned here. The hue, sorry. So look for hue and style and size. You should be able to find a web page, probably on the Seaborn site, that will show you some examples of what those do. Oh, tip on that. When you're looking for stuff to see an example, type in the Google search example. So, because a lot of times you'll just get documentation with no examples. So that will usually help you figure things out. Okay. But in any case, though, this down at the end, I would like you to experiment with other choices for X and Y, particularly city versus highway. Okay. So that means if you copy this down and you have X equals city and Y equals highway or something like that, what you would expect is that city and highway are positively correlated, meaning that higher gas mileage in the city will correspond to having higher gas mileage on the highway. They won't be like exactly equal. It'll almost always be that the highway mileage is more. Um, Somebody told me that once that certain hybrid cars, it's the opposite, but I don't know about that. Anyway, though, experiment around with just changing those options. So really, when you come down to it, the stuff I'm looking for you to do today is more experimenting with changing options and getting things to run. Change something and run it. Change something and run it. When you change one thing and it breaks it and it won't run, you know what went wrong, and you can go back and change it back. Okay. Really, more than anything, experiment with stuff and find out how to do these things. Scatterplot is an especially important one to know how to do. Um, Beyond that, for presentation type stuff, not presentation to me, but presentation type stuff, when you have an actual job, you might need to know how to do these pie charts and these box plots to be able to look at things. I've seen box plots used a lot to express something that has to do with buying and selling stocks. I don't buy and sell stocks, so I don't know exactly what it's for, but it's used to do some kind of comparisons with that. So anyway, that's it. You're having to open a file from a URL, and you're having to play around with some stuff of getting the actual plots to do different things. Hopefully, you can finish that by the end of the day and get it uploaded to the Canvas site. All right. Cool. Talk to you soon.